All right, so today we're covering hard drives and file systems. There's probably a lot of stuff that you guys already know because we've talked about it in here, but you kind of get the rundown, and they're going to talk about not just Windows, but Mac and Linux and things like that too. So our module objectives here, they talk about different types of storage drives and characteristics, local structures, understanding boot process, which is very important. And you need to understand it for the three big ones there, Windows, Linux, and Mac. And then understanding the different various file systems of those operating systems. And then how to, they give us a nice little explanation of autopsy and sleuthkit, which are two of the biggies for investigating those. Okay, so first we're going to do the description of different types of disk drives and their characteristics. So this is an HDD, or the old platter spinning type. And I say old because a lot of people use SSDs. However, when you're doing big servers and stuff, a lot of times you're going to run into these anyway. So it is a non-volatile data storage device that records data magnetically on a metallic platter. The read-write performance of an HDD is directly proportional to the RPM, or revolutions per minute, of the drive platter. And here's our little anatomy broken out here. We have our slider and head, the platters. When they talk about the spindle, they're just literally talking about the thing in the center. The actuator axis, and the arm that moves the head around there. And you have your power connectors, jumper pins, and SCSI connector on this one. A lot of them now don't use SCSI. They use, wow, my brain just blanked right out. The ones that look like a little L, my brain just went. SATA, there we go. They use SATA connectors. But you know, you might still run into these, especially if you're doing proprietary industries. The SCSI connectors are used on some of those as well. So understanding hard drives, tracks. Tracks are concentric circles on the platter where all the information is stored. The drive head can access the circular rings in one position at a time. They are numbered for identification purposes, and the read-write is performed by rolling headers from the inner to outermost part of the disk. So here's your example. And I like that they actually show it, you know, vertically instead of, you know, because usually you just see it from the top down, but this is what it looks like from the side. For track numbering, so track numbering on a hard disk begins at 0 from the outer edge, and then it moves towards the center. Number of tracks on a hard disk depend on the size of the disk. The read-write heads on both surfaces of the platter are tightly packed and locked together on an assembly of head arms, and you can see those down here. The arms move in and out together to physically locate all heads at the same track number. Therefore, a track location is often referred to by a cylinder number rather than a track number. A cylinder is a group of all tracks that start at the same head position. So you can kind of see what they're talking about there. It's been a long time. Most laptops that I've seen now, you have to get an external one, or you have to have an option to say, yes, put a CD drive or a DVD drive or a blue whatever on there.
I mean, I bought an iBuyPower laptop for gaming when I was deployed in like 2011. It came with a CD drive, but
yeah, I will say same thing, guys. iBuyPower too, yeah.
yeah, like
That was like 2011, 2012, yeah.
Yeah,
So,
it's been a long time. Yeah.
They might want to consider updating their slides a little bit.
Well, this one is actually because
I think it
they
was
go
like
from the oldest to the newest on technology.
Yeah, I was talking about like 2 slides before that when it showed like the laptop.
Oh,
There
that,
you go.
yeah, yeah. I will say though, criminals aren't always up to date when it comes to using certain things.
Well, especially if they're just getting them cheap, they use we found 4 or 5
Pawn
laptops
shops.
just
Yeah,
just networked together.
yep. Okay. Sectors on a hard drive. The sector is the smallest physical storage unit on the disk platter. Each sector holds a fixed size of 512 bytes for HDDs, two 2048 bytes for CD-ROMs and DVDs, and the latest HDDs are 4096 or 4 KB sectors. Each disk sector is labeled using factory tracking position data. The optimal method of storing a file on a disk is in contiguous series, which means one after the other. For example, if the file size is 600 bytes, two 512 byte sectors are allocated for the file. Understanding hard drive sector addressing. So you can see over here, we've got our platters, the spindle, and the little arm. Cylinders, heads, and sectors determine the address of individual sectors on the disk. When a disk is formatted, it's divided into tracks and sectors. For example, the formatted disk might contain 50 tracks, each of which is divided into 10 sectors. Track and sector numbers are used by the operating system and disk drive to identify stored information. 4K sectors. So this is for your new ones, for advanced format sectors. Generation 1 advanced format, also called 4K sector technology, efficiently uses the storage surface media of a disk by merging 8 512 byte sectors into a single sector of your 4K bytes. And you can see down here the example of what that looks like. So there's your 8 512s, and then you can see your 1 4K down here on the bottom. Data density on a hard disk. Data is recorded into a hard disk using a method called zoned bit recording or multiple zone recording. In this technique, tracks are combined together into zones depending on their distance from the center of the disk. Each zone is assigned a number of sectors per track, and the types of data density on a hard disk are track density. This is defined as the space between tracks on a disk. Areal density, it's defined as the number of bits per square inch on a platter. And bit density, it's the bits per unit length of the track. CHS, or that cylinder head sector data addressing, and disk capacity calculation. There are tools that you can use to do all of this. And just so you know, after lecture, all of these slides will be up for you to look at and download. CHS addressing method addresses each physical block of data on a hard disk by specifying the cylinder, the radius, the head, the platter side, and the sector, which is the angular position. Example of disk capacity calculations is right here. No, I am not a jerk. I am not going to make test questions with that on it because I had to do those and I just look them up in tables now. So it's just rude. Anyway, that's your example. Measuring hard disk performance. Now, this is something you probably will need. Data is stored on the hard disk in the form of files. When running program requests a file, the hard disk recovers the byte content of the file and sends the byte to the CPU one at a time for further processing. Hard disk performance is measured by data rate. That's the ratio of the number of bytes per second the hard disk sends to the CPU, and what's called seek time. And that's the amount of time required to send the first byte of the file to the CPU when it requests the file. Now, a lot of these, you don't have to know how to do the math behind it unless you're a math person and you want to learn how to do that, you might need to know a little bit, but you need to understand some of the stuff so that you can intelligently talk about how things degrade. I was specifically asked a lot about degradation of hard disk performance because people wanted to know how long things could stay stored or how long it would take, how many times they could take images and things like that. So you just need to have at least a little bit of knowledge of some of these. Next, the one that I think you're going to see more, SSDs, solid state hard drives. This is a non-volatile storage device that uses what's called NAND flash memory chips to store digital data. They are faster than HDDs as they don't have any moving parts, and the read-write performance depends on data connection of the drive. So NAND was developed off of the technology that we used originally for computer memory. And someone was like, well, we can do this and make a hard drive out of it. And that's how they developed these. So NAND flash memory is the main data storage unit made of floating gate transistors, which retain the charge state even without power. Now there's something I'll have to talk to you about for a second here. Control is a processor that acts as a bridge between the flash memory components and the computer host by executing firmware level software. DRAM, this is the volatile memory that provides the faster read-write performance. And then you have what's called your host interface. Connects to the host machine using your interface. Those are your SATA, PCI, SCSI, etc. It's usually SATA. So when you talk about NAND flash memory and charge state, one thing that you need to be aware of is that a lot of times you're asked, how long can we keep this hard drive in storage? And you just need to make people aware that when they're using an SSD, that NAND charge state eventually does run out. So if you're, I mean, it takes a really long time, but people need to be aware of how this works. So I have had to explain this slide literally probably hundreds of times to people to explain why there are still reasons for people to buy HDDs. And that's just because the charge state on these drives can run out if they're not plugged in. So if you're going to be doing things where you're storing it offline, an HDD or something that doesn't use NAND flash memory is preferable. Okay, disk interfaces. ATA, PATA, and this is the IDE. So Advanced Technology Attachment, official ANSI or American National Standards Institute name of Integrated Drive or IDE. This is your old style standard interface between motherboard and data bus and storage disk.
Honestly, not gonna lie, I never thought we'd come back to like the interface cables that we did in the first semester.
You wouldn't think so, but forensics, one of the things you need for your toolkits is
interface cables.
Cables, yeah. More often than not, that's one of the things that people look for, cables and adapters. Serial ATA or SATA is an advancement of your ATA and uses serial signaling, unlike IDE's parallel signaling. Then you have your serial attached SCSI or SAS. And this is a successor, an advanced alternative to parallel SCSI in your enterprise environments. Then you have your PCIe STD, and this is your peripheral component interconnect express. It's high-speed serial expansion card that integrates flash directly onto the motherboard. And then SCSI, which is small computer system interface, and that refers to a set of ANSI standards interfaces based on parallel bus structure and designed to connect multiple peripherals to a computer. Now, I have seen SCSI and IDE, especially on medical technology and forensic technology. And by that, I mean your gas chromatograms, your blood alcohol machine. For some reason, a lot of them, they mature very slowly, because once they find a way to stick with certain things, they stay with it. So a lot of times these don't, the old GCMS, which is your gas chromatograph mass spectrometer that the forensic lab had, actually had IDE hookups for a lot of the stuff in there. And, you know, these are fairly advanced pieces of equipment, but they also have to be advanced enough, and they also have stability. So people are wary about changing certain interfaces. So that's why a lot of times you'll see some of the old stuff mixed in with really new technology. It's kind of an odd dichotomy on the different industries. And when it comes to medical equipment, I don't know if there's anyone that's ever worked in the medical IT industry, but they're kind of the same way. The hardware from that equipment does not advance very quickly on certain things. Sometimes when you go into a hospital, if you get a chance and you have someone that's, you can tell I've been to the hospital a lot. But if I get someone that's a nerd, I'll talk to them about the equipment. And some of the nurses love to talk about the equipment, about, oh, this is a piece of crap and it does this and that and this, and they'll even let you look at it. And you can, if you look at it, you're like, wow, this is essentially an old Windows 98 distribution that's been upgraded, and it's kind of terrifying to look at it from that side. So having all of these cables seems like, oh, I'm never going to use these, but really it just depends on what industries. Yeah, they're a different kind of nerd. Absolutely, yes. Nurses are a different kind of nerd. And if you get one that's like, if you're doing imaging or anything like that, yeah, they do. It depends on the hospital and the pieces of equipment. But I was surprised how many of them had, they call them proprietary operating systems and stuff. But if you look at it, the base underlying system that it's built on top of is like really old. So it's a good idea to have knowledge of that old stuff if you're dealing with them.
I was gonna say, that sounds kind of like Christmas if you're not exactly on the right side of the one.
Yes.
Database.
There you go, Gwen. As someone who worked as a nurse's aide in a hospital equipment is ancient. Yes, it is. That's why a lot of times hospitals are, yeah, and they wonder why they keep getting hacked. And those of us who have actually looked at the equipment don't wonder at all. It's 100% not something we wonder about. Okay, logical structures of disks. So the logical structure of a hard disk is the file system and software utilized to control the storage on the disk. Hard disk's logical structure has a significant influence on performance, consistency, expandability, and compatibility of the storage subsystem of the hard disk. Different OSs have different file systems and use various methods of arranging and controlling access to data on the hard disk. So, clusters. A cluster is the smallest logical storage unit on a hard disk. It is a set of sectors within a disk ranging from cluster number 2 to 32 or more, depending on the formatting scheme in use. The file system divides the storage on a disk volume into discrete chunks of data for efficient disk usage and performance. These chunks are called clusters. The process by which files are allocated to a cluster is called allocation. Therefore, clusters are also known as, allocation units. In the file allocation table or FAT file system, the clusters linked with file keep track of file data in the hard disk's file allocation table. Okay, cluster size. Cluster size has significant impact on the performance of an operating system and disk utilization. Cluster size can be altered for optimum disk storage. The size of the cluster depends on the size of the disk partition and the type of file system installed on that partition. A large cluster size, greater than 1 sector, has the following effects. It minimizes fragmentation problems, increases the probability of unused space in the cluster, reduces disk storage area in which information can be saved, and it reduces the unused area on the disk. Lost clusters. So when the OS marks clusters as used, but does not allocate them to any file, such clusters are known as lost clusters. A lost cluster is a FAT file system error that results from the manner in which the FAT file system allocates space and chains files together. It is mainly the result of a logical structure error and not a physical disk error. They usually occur because of interrupted file activities caused when, for example, a file is not properly closed. Thus, the cluster involved in such activity are never linked correctly to the file. Check disk is a system tool in Windows that authenticates the file system reliability of a volume and repairs logical file system errors. Slack space. Slack space is the storage area of a disk between the end of a file and the end of a cluster. If the file size is less than the cluster size, a full cluster is still assigned to that file. The remaining unused space is called slack space. For example, if the partition size is 4 gigs, each cluster will be 32 kilobytes in size. Even if the file requires only 10, then the entire 32 will be allocated to that file, resulting in 22 kilobytes of slack space. Master boot record. You've heard me talk about this a couple of times, especially when talking about viruses. So an MBR is the first sector or sector 0 of a data storage device like a hard drive. The information regarding the files on the disk, their locations and sizes, and other important data is stored on your MBR. In practice, MBR is almost always referred to a 512-byte boot sector or partition sector of a disk. The MBR is used for the following: holding a partition table, which refers to the partitions of the hard disk, bootstrapping an OS, distinctively recognizing individual hard disk media with a 32-bit disk signature. So what is our structure of the MBR? It consists of 3 parts: master boot code or bootstrap. It's an executable code and responsible for loading operating system into computer memory. Consists of data structure of 446 bytes. Then you have your partition table, which maintains the data of all the hard disk partitions and consists of data structure of 64 bytes. And then your disk signature, which is allocated at the end of the MBR and contains only 2 bytes of data. It is required by BIOS during boot. And you can see over here on the right, the nice little table that shows you the hex, octet, and DEC of that, if you want to know. Disk partitions. Now, disk partitions you will find if you're doing anything with forensics, eventually you're going to run into this, probably sooner rather than later. Disk partitioning is creation of logical divisions on storage devices, hard drives, HDDs, and SSDs to allow the user to apply OS-specific logic formatting. This partitioning process is the same for both HDDs and SSDs. You have your primary partition, and that's the drive that holds the information regarding the OS, system area, and other information required for booting. In MS-DOS, the earlier versions of Microsoft Windows systems, the first partition, the C drive, must be a primary partition. And then, okay, just watch the rest of it when you get a chance, Josh. Extended partition. This is just a logical drive that holds information regarding stored data and files on the disk. BIOS parameter block, or BPB. This is a data structure in the partition boot sector. It describes physical layout of data storage volumes, such as the number of heads and the size of the tracks on the drive. In a file system like FAT12, and I'll be surprised if you run into FAT12 or FAT16. FAT32 you might run into. Most of the new systems use what's called the NTFS, but I say that, and there are some specialty stuff that you may run into that have them out there, so it's good to be aware of these. So FAT12, FAT16, FAT32, HPFS, which is high performance file system, and NTFS, which is new technology file system. That's what like Windows 10, 11, all those use. Those define the file system structure. The BP length varies for the FAT16, 32, and NTF boot sectors due to different types of fields and the amount of data stored in them. It assists investigators to locate the file table on the hard drive. So if you know what file structure you are, but you have to figure out where your file table might be, because sometimes they become disassociated, or when someone's trying to destroy data, they can cause all sorts of issues, and you may have to go look for this stuff manually. So that's why you have tables like this. A GUID, or globally unique identifier. GUID is a 128-bit unique reference number used as an identifier in computer software. In general, GUIDs are displayed as 32 hexadecimal digits with groups separated by hyphens. You can see down here, there's a registry editor, and you can see the number letter sections right there of the GUIDs. So the common uses in Windows Registry, GUIDs are used to identify COM, or component object model, and DLLs, or dynamic link libraries. In database tables, they're used as primary key values. In some instances, websites may assign a GUID to a user's browser to record and track sessions, and Windows assigns a GUID to a username to identify user accounts. So you will run into this in Windows forensics. So a GPT, or a GUID partition table, this is, if you look over here on the right, you'll see your GUID partition table scheme. UEFI, which is the replacement for BIOS firmware. Basically, the difference in UEFI and BIOS is command line. UEFI is you can use a mouse. Yes, all the acronyms. I will say that digital forensics has a lot of acronyms. So UEFI is, those are the two types of firmware that you can run into. Most computers use UEFI now, unless, again, they're specialty. However, if you're using something that's older, you're going to run into BIOS. UEFI is a specification that defines software interface between the OS and platform firmware. It uses a partition system known as GPT, or GUID partition table, and that replaces the traditional master boot record. So what are the advantages? It supports 128 partitions and uses 64-bit logical block addresses. Supports a maximum partition size ranging from 2 tebibytes to 8 zebibytes. I would have to go out and do the math and tell you exactly what that is. Provides primary and backup partition tables for redundancy. I will just say really, really big. You know, it could be. You never know. Yeah, I will say D&D, DoD, everybody likes acronyms. And one thing you're running into with forensics, there's a crossover in forensics and cybersecurity, but there are some things that mean different things between those. So booting process. So booting, we're talking about the process of starting or restarting the operating system. When the user turns the computer system on, it loads the operating system stored in the hard disk to the RAM, which is your working memory. The types of booting, you guys probably should know this, your cold boot or hard boot, and warm boot or soft boot. The hard boot's your power down or off state. Warm boot is basically when it's turned on and you're doing like a reboot or something like that.
Well, of course, cold boots are hard. They're cold.
It's too cold. Okay.
Have you ever tried putting on a cold boot? It's not pleasant.
Well, I do live in Idaho, so yes, I have. Windows, essential Windows system files. This is a nice little table. It will actually tell you the file names and their descriptions. And it's nice if you're like, okay, what does this thing that I just found do? This is a nice little map. It's a flow chart of the Windows boot process. And this is the BIOS to master boot record method. This is Windows XP, Vista, and 7 use this method. And then the newer ones use the UFI GPT method. And I'm going to go past these because we can look at these ourselves, and you'll have access to all of these slides out in course documents after lecture. So how do you identify the master boot record? So if you go into computer management, disk management, if you look under properties for your main drive, if you look under partition style, you'll find master boot record. So that's how you can check. Vista, oh, Vista made me cry. I hated working on Vista. Well, it didn't make me cry, but it made me hate life for a while. This is the UFI GPT boot record. Notice how it's a lot more linear. So there's a bit of a difference there. Identifying the GUID partition table. Investigators can use commandlets given below in Windows PowerShell to identify PowerShell, to identify the presence of GPT. There's a get GPT. This parses the GPT data structure contained in the first few sectors of the device. Specified requires the use of path parameter, which takes the Win32 device namespace, you can see it here, for the device from which the GPT should parse. And then if get GPT is run against a disk formatted with an MBR, it will throw an error prompting to use get MBR instead. So that'll let you know right away that it's not using GPT. And then there's an alternate method. You can go into computer management, same thing, disk management properties, volumes, partition style. So sometimes they use these automated, they'll make automated commandlets just because if you're running a whole bunch of hard drives and you're trying to gather specific data, and it's just easier to throw a whole bunch of automated commandlets rather than physically going out and clicking through stuff. So get boot sector. It reviews the hard drive's first sector and determines if the disk is formatted using MBR or GPT. And then once done, it acts just as get MBR or get GPT would, respectively. And then it shows you that here below. And then there's get partition table, determines the type of boot sector and returns correct partition objective. And you can see those here. Analyzing the GPT header and entries. So most OSs that support GPT disk access provide basic partitioning tools, which display details about GPTs. There's disk part tool, OS X, there's disk utility, that's for Mac. And then there's GNU parted tool, which is for Linux. And those are very basic. And I will say that it's always a really good idea to find an extended version of something to work with. Like parted magic was an old one. I don't know if that one's still around, but anything that gives you, because those give you very basic details, but partitions are always something in digital forensics that you're going to have to work with. Sleuth kit can be used to view detailed partition layout. And then alternatively, details about GPT header and partition entries can be obtained via manual analysis if you really want to with a hex editor. GPT artifacts. So this is an example, deleted and overwritten GUID partitions. So if you're trying to see if they deleted stuff or overwrote stuff to try and hide it, here's some examples. Case 1, if the MBR disk is repartitioned or converted to GPT, then sector 0 will generally be overwritten with a protective MBR. To recover data from previously MBR partition volumes, investigators can use standard forensic methods used to perform an extensive search for file systems. And then if the GPT disk is repartitioned or converted to MBR, then GPT header and tables may remain intact based on the tools used. So you may already have those there. Implementation of general partition deletion tools on a GPT disk might only delete protective MBR, which can be recreated by simply reconstructing the disk. Excuse me. As per UFI specifications, if all the fields in the partition entry are zeroed, it implies the entry is not in use. In this case, data recovered from a deleted GUID partition entry is not possible. GUID identifiers. GPT scheme provides GUIDs for investigative value as they are unique and hold potentially useful information within them. GUIDs possess unique identifying information for both disks and individual partitions. Investors can use tools such as UUID to decode various versions of GUID and UUID. And then if you're looking for hidden information on GPT disks, intruders may hide data on them. As they do, you can see them hide them in MBR disks. Locations on GPT disks where data may be hidden are interpartition gaps, unpartitioned space towards the end of the disk, GPT headers, and reserve areas. Current forensic methods and tools to perform GPT analysis are unsatisfactory, meaning there aren't any super specific ones that find everything. You have to overlap them to find out things. Macintosh boot process. So this is how the boot process runs for a Mac. Linux boot process. Okay. Then we're heading out to some of the other file systems. Windows file system. There's the FAT or file allocation table. FAT file system is used with DOS, and it was first file system used with Windows OS. It's named for the method of organization, the file allocation table, which resides at the beginning of the volume. There's FAT12, FAT16, and FAT32, which differ in terms of the size of entries in the FAT structure. You can see here. So it also means that there are drive size limitations, which is, like you can't have a drive over a certain size, which is why you're less likely to run into a FAT12 than you are a FAT32. There's NTFS. This is what Windows 10 and 11 and those use. It started with Windows NT and the server, Windows NT and server, and it has continued from there. It's the default file system of the Windows NT family. It has several improvements over FAT, like improved support for metadata, use of advanced data structures to improve performance, reliability, and disk-based utilization, as well as additional extensions, such as security access control lists and file system journaling. So this is what your NTFS file structure looks like. So you have your hard disk, MBR, boot sector, NTFS, there's kernel, everything else, your operating system, and then boop, over there to the user. Here's a nice table of NTFS files, system files that you might want to know about. EFS, this is the encrypting file system. First introduced in version 3.0 of NTFS and offers file system level encryption. Remember that file system level. Encryption technology maintains a level of transparency to the user who encrypted the file, which means there is no need for users to decrypt the file to access it to make changes. After a user is done with the file, the encryption policy is automatically restored. When any unauthorized user tries to access an encrypted file, they're denied access. To enable the encryption and decryption facilities, a user must set encryption attributes of the file and folders they wish to encrypt or decrypt. So it's not there automatically, it's something that they have to turn on. But, you know, as forensics people, we need to be aware of encryption tools because that's one of the things that people use the most to hide things from us. Sparse files. Sparse files provide a method of saving disk space for files, allowing the I/O subsystem to allocate only meaningful, which is non-zero, data. And there's an example down here without sparse file, and then with sparse file. And as you can see, it's not as jumbled that way. If NTFS marks a file as sparse, it assigns a hard disk cluster only for the data defined by the application. Non-defined data of the file are represented by non-allocated space on the disk. Linux, which is actually much more interesting to me than the other file systems. So this is what your Linux file system architecture looks like. User space and kernel space are split. Here is what your file hierarchy system, which is what it's called, looks like. FHS defines the directory structure and its contents in Linux and Unix like OSs. In FHS, all files and directories are present under the root directory with the slash. There's extended file system. And I know I don't expect you to be like, I know what that is. After this, I know that your brain's probably on the verge of leaking out your ears. There's a lot of these slides. Don't be surprised if you have maybe a 10% retention on some of this. You probably know more of this than you realize. Do yourself a favor and go back and look at these slides after we're done. So extended file system, or EXT, is the first file system for Linux OS to overcome certain limitations of the Minix file system. Has maximum partition size of 2 gig and maximum file name size of 255. I will tell you right now, these EXTs, the difference in the EXT 2.3 is usually about the size of the files. It was replaced by EXT2. It removes, sorry, I went backwards there. It removes 2 major Minix file system limitations, which is it changes your maximum partition style size, and it gives you a longer file name character limit. Major limitation in file system is that it does not support separate access, inode modification, and data modification timestamp. Then AXT2, I will tell you, if you ever take any of the forensic exams, you will get questions on what is EXT, what is EXT2, what is EXT3. So just be aware of that. EXT2 is the next iteration. It used improved algorithms. What?
They're the order in which we got visited by extraterrestrial races.
I cannot hear you.
They're the order in which we got visited by aliens.
There you go. Yes.
1, 2,
yes.
3.
Yes, they're the really bad sequel names. Anyway, so this one greatly enhances the speed and maintains additional timestamps, maintains a special field in the superblock that keeps track of file system status and identifies it either clean or dirty. Major shortcomings are the risk of file system corruption when writing to ext2 and the lack of what's called journaling. So what do you think is coming in ext3? Journaling. So this is the next version, the next upgrade. Again, it improves greatly. Each version of these improves greatly on the next one. It has file system maintenance utilities for maintenance and repair. Has an enhanced version of the ext2 file system. And then you have a conversion command here. So it has data integrity, speed, and easy transition. So what is the journaling file system? This is actually really important when you're talking about Linux. Journaling file systems ensure data integrity on a computer, which is why they went to ext3. These file systems consist of a journal that records all the information on the updates that are ready to be applied to the file system before they are applied. This mechanism is referred to as journaling. Journaling prevents data corruption. So this was specifically implemented to fix that data corruption problem that ext2 had. Excuse me, by restoring the data on the hard disk to the state it existed in before the occurrence of a system crash or power failure. This helps the system to resume the completion of tasks or updates that were interrupted by an unexpected event. So these are some of the examples of journaling file systems on Linux. The ones that are there, ext3, 4, ZF, and XFS. Because of its stability, ext4, which is now out, is the most commonly implemented file system for Linux. So what is the ext4? It has journaling that it developed as a replacement of the commonly used ext3 file system. It also incorporated new features, has a significant advantage over the previous versions, particularly in terms of performance, scalability, and reliability. And it also supports newer Linux kernel versions. So this is an example of what that disk layout looks like. So Mac OS, yes, they're out there. Yes, you will have to do data forensics on them. There is UFS. It's derived from the Berkeley Fast File System that was originally developed at Bell Laboratory from the first version of Unix. All BSD Unix derivatives include FreeSP, NetBSD, OpenBSD, all that list there. Then there's Hierarchical File System, which was developed by Apple. And then there's HFS Plus, which is the successor. And then there's Apple File System. And this is the proprietary system developed by Apple Inc. And it's from 10.3 and later. Or I will say the other area that you're going to see a lot of people that use Macs and hold on. My cough's been bad. Graphics. For some reason, they really laid in hard to the drawing and art sectors. So they have a lot of those.
Yeah, but like whenever ever met someone who's in drawing and art sector, ever be sane.
Hey now, that's where I started.
You're not making a valid argument here.
You're like, but you started there and you went somewhere else. So that means you're now actually what happened was I saw what you have to be to become a commercial artist and how you basically have to sell your soul, and decided I'd rather have it as a hobby than something I wanted to have be paid for. So that's my personal opinion though. So not the colleges, that is not reflected by them. That is my personal opinion. This is what HFS looks like. This is Apple file system. It has two layers. It has a container and a file system layer. So All that for the actual fun thing. File system analysis. So this is autopsy. This is what with the window. You remember that really awful one that was built into Kane? This is what the new one actually looks like. This is a digital forensics platform and graphical interface to the sleuth kit and other digital forensic tools. And you can do all sorts of things. If you look over here on the left where it says data source, this is actually all sorts of files that you can work through. And you can see modified times, and you'll see a slider bar down there, so you're not seeing everything, but there are tons and tons and tons of things that you can see there. And if you look at the top, you see where it says timeline. Remember us talking briefly about timelining this. This brings up really excellent timelining. Then there is TSK, which is Sleuth Kit. This is a library and collection of command. These are all command line tools that allow investigators to look at the volume and file system data. File system tools allow you to examine the file system of the suspect computer in a non-intrusive fashion. So that allows you to look at those nice forensically copied things and not change the things that you're looking at. Just dig through everything to find stuff. It supports DOS, BSD, Mac, Sun, GPT. It goes through RAW, Expert Witness, which is NCASE, uses that, and the AFF file system. And then it supports all those different file systems on the bottom. So, recovering deleted files from a hard disk using WinHex. So this is a hexadecimal editor that you can use for computer forensics, data recovery, and low-level data processing, and IT security. There's some stuff you can do there. It's mainly used to inspect and edit all types of files, to recover deleted files or lost data from hard drives with corrupt file systems, or from memory cards or digital cameras. As you can see here, we have just a pile of stuff. And if you're really good with WinHex, good for you. It's never been one that I'm particularly fond of. Okay, module summary. So now that your brains have leaked in, kind of plugged the ear, what did we talk about? Different storage drives and their characteristics, logical structures of your disks, different boot processes for Windows, Linux, and Mac. Then this module, we also talked about all those different file systems for Windows, Linux, and Mac. And then we'd had a little bit of a discussion on examining file systems with Autopsy and Sleuth Kit. So on Wednesday, we will talk about data acquisition and duplication, which you guys already have a little bit of a taste from, because we already looked at how to use an imager, which is the acquisition and duplication portion of just one thing. So I'm going to stop share here. So that is where we're going to go on Wednesday. All right, so I'm going to end the recording right here, and then I'm going to chat to you guys about some homework.